Welcome to the Green Transition Show with me, Dr. Francis Tokun. Sustainability is a contested concept, or it's a slippery concept. It means different things to different people. In today's episode of the Green Transition Show, we want to find out whether we can have sustainable and safe mining. With me to have this discussion is Patrick Bayobie. Welcome to the show, Patrick.
Yeah, thank you, Dr. Francis. It is a great honor and a pleasure to join in this show this morning. I know this is a 33 session or so. Am I right?
Yes, that's right. Yeah.
Yes. Once again, it's a great pleasure. And I want to use that opportunity to also welcome other practitioners, HSC professionals, geoscientists, regulators, students, and other sustainability advocates, for making time to join us on this wonderful show. I'm very sure it's going to be an exciting one.
Yes,
and
I
we
believe
hope
so.
you will all enjoy it. Sure.
Yes, yes, I believe so. If you are watching us for the first time, this is the Green Transition Show. Kindly go to YouTube, hit the subscribe button, comment on our videos, like our videos, share them. This will motivate us to continue to bring you such insightful conversations. You can also follow us on TikTok, LinkedIn, and on Facebook. We are currently live on Facebook. Patrick, kindly introduce yourself to our audience and tell us what you do.
Yeah, thank you very much. Like you rightly mentioned, my name is Patrick Bayobie. I am a geoscientist trained professionally in Ghana here. I had my first degree from the University for Development Studies, then proceeded to University of Ghana, Legon, where I graduated from that place, and currently advancing my PhD at the University of Mines and Technology, Takwa. And my professional interest is practically based in mineral exploration, occupational health and safety, environmental management, and of course, sustainable or responsible mining. My work and experience or exposure so far has shown me that mineral development is most successful when technical performance and then worker protection, environmental stewardship, and community trust are all managed together. Geoscience practically, as we all know, it's not just only about mineral deposit discoveries and all that. It also helps us understand the ground conditions, water management systems, geotechnical risk that we are exposed to, and some of the natural constraints that influences whether a project can be sustainable or not. So my perspective as a geoscientist, therefore, connects the early exploration stages to the entire mining life cycle. And when we talk about the mining life cycle, what are we trying to say? Meaning that within every mine operation, meaning there is a stipulated time frame that the reserve is going to be extracted. So the geoscience background also captures on all these things, right from the land access to the drilling operations, through the tailings management, rehabilitations, and the closure. Thank you.
Thanks for that detailed introduction and putting the issues in proper context for our audience. When people hear the word mining, they often think about environmental destruction, pollution, and unsafe conditions. From your perspective as a geoscientist, can mining genuinely be both safe and environmentally sustainable? You started off with that, but can you add more to that based on the question I've just posed?
Yes, the answer is yes. Mining can be both safe and environmentally sustainable, but it is not automatic. When I say it is not automatic, what I'm trying to say is that mining cannot be impact-free. Right from the exploration stage to the drilling process, to mining, to rehabilitation, like I try to explain through using the mine cycle or mine life illustration. Every stage has impact on the environment. So it is true, such people, their fear is understood in some contexts. But mining in general, like I said, cannot be impact-free because it removes materials and disturbs the land. It can, however, be made safer and more sustainable when the impact are well anticipated by management of the companies. When the impact can be avoided wherever it is possible. When the impact is minimized, monitored, progressively corrected, and transparently reported throughout the whole project lifecycle. The test is not whether mining has a zero impact. It is whether there are alternatives that can be assessed, whether the residual impacts are acceptable in the society or within the neighboring communities, whether the operator is competent enough to ensure environmental sustainability, whether the operator has the financial capacity to be able to manage it and govern this exposure that the environment is exposed to. When you look at the context of safety and sustainability, the two of these can always or must always be influenced by investment decisions. Again, by mine design and production planning protocols. If they are just treated separately, then you realize that the preventive measures may be weaker. So a sustainable mine should aim at protecting people. That is why in recent times, most mining companies prioritizes the health and safety right from the operations to equipment usage to their workers, and in direct consonance to the provisions of the regulations. A mine, again, can be sustainable when the materials intensity, human rights are respected. When there's a value that is created by the local communities, then they should also be ready to rehabilitate the lands and retain adequate financial provisions towards the closure and the post-closure obligations. Without this, it is difficult to attain sustainability. But the bottom line is management commitment. If the management of the institution of the mine in question is not committed, then there will always be lapses. When these lapses come, then it affects the sustainability protocols. So the answer is yes, mining can be much safer and sustainable in life in general.
So it means that sustainability in mining doesn't necessarily mean environmental compliance or environmental sustainability. It means that you are going to integrate environmental, social, and economic dimensions or principles into the operations of the mines. So it's not just restricted to only one aspect. Because when we talk about sustainability, many people see it as environmental, right? Environmental sustainability. They look at it from one aspect or one dimension, but it encapsulates or includes environmental dimension, social dimension, and economic dimension. Now, sustainability discussions often focus on active mines, but environmental impacts can begin much earlier. So this discussion is not just focused on one aspect of mining. Like you said, we are looking at the entire life cycle of mining, from exploration to tailings to mine closure. We are looking at all of that. What environmental and social risks can arise during mineral exploration? Oftentimes, we don't look at the exploration. We're interested in the mines. We're interested in mining, right? The actual mining. But exploration is key. So what environmental and social risks can arise during mineral exploration? And how can mining companies minimize these impacts from the very beginning?
Yeah, thank you very much. Exploration has a smaller footprint than producing mines, but its impact, like you said, begins immediately. Key risks include vegetation clearance, erosion, drilling fluid and or fuel releases, poorly closed drill sums, dust production, noise, road safety exposure, waste, water abstractions, livelihood disturbances, and above all, conflict over land access and compensations. Fortunately, in Ghana, all our operations, when it comes to exploration, when it comes to mining, when it comes to the closure and all other areas, there are regulations that guide and governs these operations respectively. Now you come to these regulators. What do I mean by that? In Ghana here, we have what we call the LI 2182. And this is a document that has a lot of protocols, sections that regulates this. Specifically, in terms of exploration, Section 78 of the LI 2182 clearly gives exploration companies room, how much level of vegetation they can clear. The law also provides that once you clear the vegetation, the topsoil should be heaped at a particular location, and whatever you want to do, that is in this case of exploration, that is the drill parts. Once the drill parts are made, the topsoil is heaped, and then after the drilling is done, then the topsoil is supposed to be used back to reclaim the land and allow the vegetation to regrow. This regulation is there to help us keep the area that has been cleared sustainable, regrow, and then get back to its original state. Of course, the first and foremost control is good planning. It all boils down to good planning. The use of environmental and social baseline information is very important, because if you don't rely on the baseline information, then how do you avoid the wetlands disturbances, water courses, the steep unstable grounds, farms, sacred lands? All these areas are going to be disturbed. So most of the times, companies obtain permits and land access agreement before disturbances. And if you don't do that, how do you plan? Now, once you have also planned very well, then you have to make use of the existing tracks. When I say the existing tracks, of course, we create access across the areas that we work, from one drill part to the other. And in some cases, you have to compensate farmers, all right, before you can clear through their cocoa farms. Of course, in our quest to trying to minimize the destruction or the vegetation clearance, it is important that existing tracks are used, limiting road and path width. When I say path, because you look at the drill rigs that are being used, they have specific dimensions. So the law do not permit you to over excavate the area. And once the law do not permit you to over excavate, you are able to work. And once you are ready to comply, you are able to work in direct consonance to the provisions of these regulations. And these regulations are very, very emphatic. And apart from that, they also have drill sums that are created, and these drill sums, of course, with the fluids that comes out of the drilling process, of course, the drill sums contain or accommodate the water that is being abstracted from the streams or the rivers. All right. Once it is mixed with the chemicals, and these chemicals, of course, are biodegradable. They are biodegradable, but of course, for the meantime, it is collected in drill sums. And these drill sums contain the water. Once the drilling is done, it is rehabilitated, reclosed in that order, just to continue to prevent the runoffs into the farm streams and all that. Again, the social risk is also reduced through early and continuous engagement with the community members. Once this engagement is continuous, clear explanations are given for exploration uncertainties. Of course, there are uncertainties in some of the works that is being done. There's a fair compensation processes that is adopted. So you realize that in the case of the company where I work, for instance, so you see that we have compensation officers. Before you get into the farm, the compensation officer gets there, then they have that interaction with the farmer. Let the farmer understand there's that transparency. Once the farmer understands, it's part of the process and gets to know how many cocoa trees you are going to fall. In front of the farmer, the demarcation is done. The farmer is brought to the same location while the earthwork teams moves in and clears the vegetation according to the said location. Then before the drilling program begins. So the social risk is reduced drastically once there's that engagement with the farmer, clear explanations are given to them, and then the compensations is fair. And this is in fact done based on the national, policies, the land evaluation, policies, protocols that we have. We work in direct consonance with that. You don't do it without taking into consideration what the land valuation protocols also emphasize on. And once all these things are done, then of course the impact is reduced.
So you talked about protocols, policies, and regulations. My own work within the mining sector have revealed that the problem is not the lack of policies or regulations, but the inability or lack of capacity to implement the existing policies. What do you say to that?
That is why mostly it is important that companies have experts, competent people. Apart from just having the regulators, the policies and all that, we also have specific competent people. And competent here, what am I trying to say? I'm trying to say that such people are well trained, they have the experience, they have the skills to be able to manage these areas. Let me use the company in which I work, for instance, Newcore Gold, okay? In trying to ensure that all these things are sustained, we have myself here as part of the enforcement group, the compliance monitoring and evaluation group. We constantly move around with the workers. Of course, there are always residual effects or impact. We move around, ensure that whatever operations that are being done is done in strict consonance to the provisions. And of course, intermittently, the regulators do visit sites to check and ensure that all other measures that are in place are strictly complied by. And I can say on authority that from where I sit, based on my experience, first-hand experience, this thing is minimized to the barest minimum. Thank you.
Right. If you are watching us, this is the Green Transition Show with me, Dr. Francis Tuokun. My guest is Patrick Bayobie. We're discussing mining safety, mining sustainability from exploration to tailings. If you are watching us for the first time, kindly hit the subscribe button on YouTube. You can also follow us on Facebook, LinkedIn, and on TikTok. This will motivate us to continue to bring you such insightful conversations. I'm sure you are enjoying the conversation because I am. You can also share, like, and comment on our videos. Patrick, I want us to look at worker and community safety. Mining presents risks not only to workers, but also to surrounding communities. What technologies, practices, or approaches can mining companies use to reduce their environmental footprint while still operating economically?
Yes, when it comes to technologies, there are a lot and a lot and a lot that are being implemented. So for instance, I want to use in terms the worker safety component. Let's take, for instance, in terms of the equipment operators, because of fatigue that sets in. So you realize that in recent times, the equipments, we have these fatigue monitoring devices that are installed in the equipment in case someone maybe is falling asleep. They are like vibration sensors. It vibrates you and wakes you up to be awake, so that in case you've fallen asleep, once that happens, then of course you'll be able to stay awake and then continue to work safely as well. Apart from that, in terms of underground operations, you see that in some cases now, some companies have resorted to using drones. They use the drones, then the drones moves into the stopes in that order and survey the area for wall stability inspections. For wall stability inspections, such that if a wall is possibly failing, then with that technology or with the use of the drones, they are able to do to check and report. The data is gathered, then the right measures are used or put in place to be able to control the risk. And most importantly, in every operations, we have what we call the critical risk. The critical risk. And what do I mean by critical risks? These are risks that when you are exposed to it, the aftermath of it can be catastrophic. It can be fatal. It can cause damage to equipment. So by virtue of ensuring that control measures are in place, so companies in recent times adopt what we call the critical controls. And these critical controls are control measures that are put in place to prevent or reduce the impact when a critical risk fails. Let's take, for instance, on the 13th of August this month, if you have watched carefully, you hear the dam failure. All right, you hear the dam failure, and when this dam failed, what happens? Meaning there's a critical risk has failed, and when that happens, the impact to the society, the environment is greatly felt. So in recent times, with the inception of these critical controls to curtail critical risk, most companies have resorted to using that, right from the vehicular interactions to the tailings management to human beings and to all other sectors, such that if one fails, the impact will be fairly reduced to the minimum. Of course, there are residual risks that we are exposed to. And these residual risks, what do I mean by that? You can put in all the control measures, but afterwards, something can still happen out of that. And when that happens, in this case, all other measures are in place. You still have to go in, investigate. The lessons are learned. Then you put in other control measures to curtail it once more. So when it comes to reducing the risks and the impact, these time companies are very, very profound, very, very active on it, and committing finances to it in order to be able to keep the workplace safe.
Water use and contamination are major concerns in mining communities. How can mining companies responsibly manage water from extraction and processing to waste, water treatment and reuse, while also protecting local water resources?
Thank you very much, Dr. Francis. Responsible water management begins with the catchment, not the mine fence. A company must understand that a company must understand that the water usage must depend on how the water flows in, the quality changes on seasonal basis. The company again must understand how climate risk affect availability. The company must also understand how its operations is impacting on the withdrawal, the storage, and the discharge of the water, and how it affects the ecosystems. The operational hierarchy in most companies in terms of water usage is to avoid unnecessary use of the water, is to reduce the demand, separate clean water from contact water, reuse, recycle processed water, treat water for usage, and discharge it only when it is approved and monitored. Most companies, in their quest to ensuring that this water is managed well, sometimes most companies give out the water management systems to contractors. So in some cases, if you have heard of Veolia, all right, some companies, give water management system to Veolia. We also have other companies, Xylem, and these are all companies that are well versed in terms of water usage. Again, within the same context, we also have what we call a site-wide water balance. This is where you look at the amount of water that is flowing in through rainfall, then compare that to how much you are abstracting based on your operations. So once that is established, you are able to tell how your operations is impacting on the water that you are using, because the water also plays a critical role in sustainability. Again, we also look at the extreme rainfall conditions. Then once that is done, you monitor the abstractions, the storage capacity, the groundwater levels, the surface water inflows, the sediment chemistry, downstream receptors, the trigger levels. All these things are done. And once that is done, the source is possibly shared. So companies in recent times have structures in place that discloses the meaningful usage of the water, engages the communities within which they are operating in monitoring where appropriate, and avoid claiming that regulatory compliance alone proves that there is no community impact. So in terms of water usage, a lot of measures are in place, right from the design stage to the pollution preventions at the source. The treatment is the last line of defense. The treatment is the last line of defense. Thank you.
Yeah, I want us to talk about tailings. What are tailings? Many people don't understand what tailings mean. So what are tailings? And tailings failures around the world have caused devastating environmental and human consequences. Why is tailings management such a critical sustainability and safety issue? And where do you think the industry is still falling short?
Thank you. Tailing facilities in general can retain enormous volume of saturated waste for a decade or permanently. The failure may be sudden.
What are tailings in the first place? If some of our audience who are not familiar with the mining sector may not understand.
Yeah, the tailings is just simply a slurry. Okay, in simple terms, it's just a slurry that comes out of what? The processing of the minerals or the ore. And once that comes out in the form of that slurry, it is now moved to a storage center. Then that's where we call what? The tailings dump. So in brief terms, the tailings is simply what? A slurry that is mixed with chemicals, mud, other fine particles and all that. Thank you.
Yeah.
Now, once we understand the context of what a tailings is, like I said, and most tailings facilities retains enormous volume of what? Saturated waste. And these things can be stored for decades. The failure, like you mentioned, may be sudden. It can travel far beyond the mine boundaries, cause multiple fatalities, affect ecosystems, and then the long-term loss of trust. By virtue of this, tailings must therefore be governed as a major hazard system throughout the design stage, throughout the operations of the mine, throughout the closure and the post-closure stage. One interesting thing is that most industries sometimes treat tailings as a mere waste disposal function instead of treating it as a core engineering responsibility. And once this common weakness is not identified, and some of these common weaknesses are incomplete site characterizations, poor water management system, constructions that depart from the design, fragmented accountability issues, inadequate changes in management, and failure to act on the monitoring data. When all these weaknesses are not taken into consideration, then you realize that the failure can occur. And when that happens, it affects a lot of systems. The environment per se suffers it. The global industry standard on tailings management has organized around 6 major areas with 15 principles that helps us manage these tailings. And the emphasis is affected people. An interdisciplinary knowledge base, consequences-led design monitoring, emergency preparedness, public disclosure, and senior accountability are some of these things that must be focused on. You cannot also talk about tailings safety or tailings dump management systems without looking at competent engineers. Competent engineers, independent review and reliability of data, regulator capacity, and a culture that escalates concerns before stability margins are lost. So in tailings management, a lot of priority is put on the governance and the engineering components. If it is not managed well, the emergency plans will not also be looked at it critically, and when the impact occurs, it affects the environment and the human beings at large.
There's also a concept called tailings dewatering. What exactly is tailings dewatering, and how does it work? And how can it help to reduce water consumption, environmental risks, and the potential for catastrophic tailings failures?
Yeah, tailings dewatering is a process where we remove, where we remove processed water from the tailings before the final storage. Processed water is removed from the tailings before the final storage. Because right from the processing plant, when it comes out in the form of that slurry, so once it comes out from the form of that slurry, it goes to the thickening stage. Once it gets to the thickening stage, of course, goes through other processes, then it is recycled again. And when that happens, most of the time we have what we call centrifuge, the thickness, all right, the filtration processes. We have all these devices in place, and these things can produce the thickened tailings, the paste, and the filter cakes before it is what? Returned or recovered and returned back to the plant. So the essence here is just to lower the water materials that is transported and placed in a design appropriately for its what? Consistent usage. Now, dewatering can reduce freshwater demands. The volume of water that is stored behind the what? The embankment and the mobility that is released is very, very important throughout the filtration processes. And when that happens, the corrected technology should be followed with the multi-criteria alternatives. So the assessments covering geology, the seismic, climate, water balance, production rate, your energy, constructions, closure, and consequences throughout the entire life cycle cost. So in dewatering processes, it is important to always have your dewatering risk reduction controls, not a substitute for just a design per se, but you should have your dewatering risk control measures in place before the water is recovered. And this can reduce both operational demands and water-related tailings hazards. Thank you.
Among all the advances in automation, remote sensing, artificial intelligence, water recycling, etc., among all of these innovations and advances in technology, which innovations do you believe have the greatest potential to make mining safer and more sustainable over the next decade?
The way forward is technology. The way forward is just technology. And you cannot rely on technology if you don't also have the experts, the competent personnel in place. Because once we are adopting technological advances, we must also ensure that we have the competent people in place to be able to help us advance the cost. Because right from exploration stage to the drilling operations, to the tailings management, to the closure, at each of these sectors, you need competent people. And these competent people are those that will always ensure that all other protocols that are in place are strictly monitored and complied to. And that is the only way to achieve sustainability. Otherwise, they will always be failures, and that will always bring financial constraints and all that. So the best option is just making sure you have competent people monitoring your data, and when the data comes, you act on them. Where there's a need to blend that, you add technology in addition, and you'll be fine. Thank you.
The global transition to renewable energy, electric vehicles, and battery storage will require enormous quantities of minerals. How do we reconcile the need to dramatically increase mineral production with the environmental and social goals of green transition?
Yeah, what we should do is that we must just reject the false choice between mine everything and mine nothing. I repeat, I said we should reject the false choice between mine everything and mine nothing. The transition needs additional minerals, but supply must come from a portfolio of responsible mining technologies. The better use of existing access, improve recovery, substitutions where feasible, and the product durability, a much stronger reuse and recycling. And one of the things that can help us reconcile is this what? IEA reports and all those things. Having, like I mentioned earlier, having technically strong people. Like for instance, IEA reports a strong growth in the demand for lithium and other energy transition minerals. At the same time, it estimates that scaling up recycling could reduce the need for new mine development for key minerals, roughly by what, 25 to 40% in mid-centuries, depending on the type of minerals. So the projection is most producing countries or most producing mines must seek more than what, just extractions. Local skills, geological knowledge, infrastructure, supply development, transparent revenues, and value additions. All this can help convert wealthy minerals into durable national development. Apart from that, there must also be fast permitting, because you can have all this in place, but if you don't have fast permitting system, because at each stage you need a permit, and this fast permitting stage should be efficient and well resourced and with predictable decision makings, not just a weaker assessment or a reduced community right. So once we have fast permitting systems in place, we will be able to meet the demands and then work accordingly and be able to to maintain or reconcile the rising critical mineral demands towards what? Green transition goals. Thank you.
For communities that depend economically on mining, but are concerned about its environmental consequences, what should they reasonably expect and demand from a responsible mining company?
So the first option is to integrate safety, environmental, and social factors. Once companies integrate safety, environmental, and social factors into technical and financial decision makings, right from exploration, they must also strengthen accountabilities and dependent assurance. Apart from that, they must also plan and fund and implement progressive rehabilitations. And once all these are in place, then of course it goes a long way to impact positively on the neighboring communities. If all these are not done, the mindset will always be out there that the operations is always affecting the livelihood in the societies or the communities. The first and foremost thing is companies must have priorities, integrate early decision makings. Let me use my company, for instance, as an example. In our operations, understanding the impact of some of our operations, one of the key things we prioritize is baseline studies. And with the baseline studies, what do? We do it on seasonal basis, both wet and dry seasons. And in this situation, water samples are monitored, the ecosystem is monitored, the environment is also monitored. You do air, noise, dust monitoring. All these things are monitored to establish a baseline information. And once that happens, once you know that, then you're able to know how to plan your activities to be able to conform to what is good for societal consumption. So the baseline studies is very critical in helping to be able to to solve this myth. Like I also added, there should be what? Accountability that reaches the boards. And this is where very, very important. If there's no accountability, there will always be oversight responsibilities. And when that happens, the end result is the communities that will always suffer. Thank you.
What are your final words, Patrick?
Yeah, thank you. My final word is mining can support development and the green transition, but its social license must be earned every day. The future of mining should be defined not only by how much mineral we produce, but by how safely we work, how responsibly we manage water and waste, and how honestly companies engages with the communities, and what conditions we leave the land in for future generations. So I want to just also add that mining is a beautiful thing. In recent times, safety is key and the topmost priority of every mining company, right from exploration to mining and to all other sectors. Once that is prioritized, a lot of things are always worked on. Of course, leadership is also very important. I just want to use the opportunity and also say that leadership management skills is key to everything and to sustainability in general. Thank you.
Thank you so much, Patrick, for joining us on the Green Transition Show. Viewers, this is where we draw the curtain to a close. I hope you have enjoyed the show. If you have enjoyed the show like I have, kindly go to YouTube, hit the subscribe button, share our videos, comment on them, give us feedback. Also, follow us on TikTok, Facebook, and on LinkedIn. Doing so will motivate us to continue to bring you very important guests, very knowledgeable guests, experienced guests to share their knowledge and experience with us. And usually we do that every weekend. We bring you global experts. We are not restricting our guests or our experts to any particular region. We bring you global experts from across the world to share their knowledge and experience with us. So please subscribe to the channel on YouTube to motivate us to continue to bring you such insightful conversations. Once again, Patrick, thank you for joining us on the Green Transition Show. We hope to see you another time.
Thank you. I'm much honored and it's a pleasure once again to have joined the show. And thanks for the great job done so